Welcome in, everyone. In this video, I'm going to cover parallel and perpendicular lines. So the points I'll be making in this video, first about parallel lines, then about perpendicular lines, and then I'll go over some examples of how you can find these. Let's get into it. First off, parallel lines. Two lines are parallel if they have the same slope. Another thing about parallel lines is that they will never intersect, and that is because they have the same slope. So just really quickly, if I have an x and y axis here, and we draw parallel lines that have the same slope, which slope the same direction, they will never, ever touch. For perpendicular lines, the slopes are negative reciprocals, and I'll go over what that means in just a moment. Perpendicular lines intersect at a right angle, aka 90-degree angle. So, for example, if you have an x and a y axis, perpendicular lines will cross at a 90-degree angle, much like you can see with the x and the y axis. Now, when I say the slopes are negative reciprocals, say, for example, the slope of the positive line here is 3, and the slope of the negative line here is negative 1/3. A negative reciprocal, or rather, negative reciprocals are numbers that have opposite signs, and the numbers are reciprocals, aka they are flipped versions of one another. For the first example here, we want to find the equation of the line passing through 2, -3, and parallel to this line. The first thing I'm going to do is I'm going to go ahead and graph this ordered pair here. 2, -3 on the coordinate plane is here, and we just don't know which way the line should slope through that point. So what we have to do is we have to come back over here and solve this equation for y. So let's find out what y equals. If you add 3x to both sides, that zeroes out the -3x on the left, leaving you with 5y equaling 3x minus 6. From there, we can divide everything by 5 to get y solved. And you have y equals 3/5 x minus 6/5. Now we don't have to graph this line. All we're asked to do is find the equation of a line passing through this ordered pair with this slope. And we're going to use the same slope because it's parallel. I might also throw in, it doesn't say anywhere to graph it, but we're going to graph this line. So using this slope, what we'll do is we will rise 3 and run 5. And since 3 is positive, we're going to go up. And since 5 is positive, we're going to go right. So up 3, right 5, right there. We can do one more. Up 3, right 5, puts me right there. But again, we don't only go to the left, we also go to the right. So down 3, left 5, puts me there. Down 3, left 5, puts me there. And that's all the further we can go. All we have to do is draw our line, put some arrows at the end of it, and we've graphed this line. Now, we also need to find the equation of this line, and luckily, we know an ordered pair from the line. that we just graphed, and we know the slope from that line. So what we can do is we can use the point slope formula, y minus y sub 1 equals m times the quantity x minus x sub 1. And we can just substitute the numbers in as we need. So we're going to end up with y plus 3 equals 3/5 x minus 2. And we can be done. If you want to find the y-intercept, you can solve this equation for y and simplify the right side of this equation. It's not going to be nice. That line doesn't cross right at -4 or -5. So this equation of a line, I feel like, makes more sense. In this example, we're going to change it up a little bit. We're still going to find the equation of a line passing through the point 0, -4, already plotted here, and perpendicular to this line. So you can see this line is already in point slope form. So we could even graph this one if we wanted to. The last example was a little gross. And so I will, in fact, graph this line. I'm going to go ahead and graph it in yellow. So I can pick out the ordered pair here of being 8, 3 from the y value here and the x value here. And 8, 3 is way over here on the graph. All right. From there, I can see the slope is -2, and I want to make it a fraction, so I'm going to put it as -2 over 1, which means I will go down to right 1, down to right 1, down to right 1, down to right 1, and then from this point here, I'm going to go up to left 1, up to left 1. And this matches up with what a negatively sloped line looks like. So there is the original line graphed. And in fact, you can already see that the slope is -2 over 1. So if we're trying to find the slope of a line that would go through this ordered pair, or this point here, we just need to take the opposite of this slope. So from -2 to +2, let me draw a little progression here. So we're going to go -2 over 1. We want to take the opposite of this, so 2 over 1. And then we want to take the reciprocal, okay? And the reciprocal just means to flip the fraction. So the slope of our perpendicular line here is 1/2. So that means I'm just going to use that to move as we do. +1 in the numerator means we'll go up 1. +2 in the denominator means we'll move right 2. And this is what our perpendicular line will look like. And of course, down 1, left 2, down 1, left 2. And we draw in the line. There we go. Super perfect every single time. Put some arrows at the end of it, and we have at least graphed the line that is perpendicular to the one we were given. And you can see it meets at a 90-degree angle. Now we want to write the equation because that's what was being asked of us. And honestly, we could use any of these points that we plotted along the way. Now, I wouldn't recommend that because if you accidentally mismove using the slope, you don't want to use that one particular point. So what I suggest you do is go back to the point that was given to you, and we can write the equation of the new line using the point slope form again. So we found the negative reciprocal slope to be 1/2. We can use this ordered pair, 0 and -4. When we substitute those numbers into the actual point slope equation, you'll see it ends up being y plus 4 equals 1/2 times x minus 0. Now, I don't know, this doesn't feel right mathematically speaking. So I'm not going to write x minus 0 here. I'm actually going to get rid of the x minus 0 and just leave it as x. Because when you subtract 0 from x, you're still just left with x. In this last example, just simply asking the question, are the following lines parallel, perpendicular, or neither? Well, I think the easiest way to answer this question is to solve for y in both cases. So starting with the left equation, we can distribute 5 here. I think that's all we can do for this step. And we will get 5x minus 5y plus 14. Then we want to make sure we get all of the y terms on one side of the equation and anything else that isn't a y on the right side of the equation. So let's go ahead and do that. And you'll see that'll give the equation negative 5y plus x minus 15. The last step here, divide by negative 5. Oops, there we go. And we end up with y equals 1 over negative 5 plus 3. Now, even still as an adult, when I see a negative in the denominator, it freaks me out. So you're allowed to get rid of that and put it in the numerator. Okay, so here's one equation. Let's go ahead and look at this other equation. We have negative x equals 5y plus 9. There's no distributions here, so the next step is get all terms with y on one side and all terms without y on the other. There we go. We subtracted 9 from both sides. Then we just have to divide every term by 5. So let's take care of that. I don't know why I picked 5 so much, but that's what we're doing. All right, so we're left with negative x over 5 minus 9 over 5 equals y. And I'm going to rewrite this equation with the y on the left side. And in addition to that, I'm going to rewrite this so the x is behind the fraction. So we've got negative 1 over 5 x minus 9/5. All right, so here is the equation solved for y. Now we just have to compare the slopes. We have a negative 1/5 slope in the left equation. We have a negative 1/5 slope on the right equation. These lines have the same slope. And if they have the same slope, they are parallel. I sure hope this video helped you out.